This is an online lesson looking at internal energy and how it is related to specific heat capacity. First, pause the video for a couple of minutes and see if you can remember the names of the stores of energy we learned about in the energy topic. So we have our thermal and kinetic energy stores alongside light, sound and electrical energies which transfer energy from one place to another. In addition, we have our potential energies, that's gravitational potential, chemical potential and elastic potential energies, which are all types of energy stores. What type of energy do the particles in solids, liquids and gases have? Have a think about how we describe what particles in solids, liquids and gases do. So all particles in matter have kinetic energy. We know in solids this is particles vibrating, so they have very little kinetic energy. We know they have more kinetic energy in liquids, and finally in gases they have a lot of kinetic energy as they're able to move very rapidly and randomly. So what do we need to do to increase the kinetic energy of these particles in matter? We add heat energy, that is, we raise the temperature or increase the thermal energy store. We know that if we heat up a solid, eventually the increased movement of the particles and the breaking of the bonds means that the solid will turn into a liquid. And we also know that if we increase the thermal energy, keep adding heat energy, eventually a liquid will boil and turn into a gas. So we come to a definition of internal energy. And internal energy is the total energy stored within a system. And I'll come to that in a moment. By total energy, we mean the total kinetic and potential energy of all the particles in a system. If you're writing out a definition of internal energy, particularly in an exam, you need to state it's the total energy, both kinetic and potential, of all particles in that system. Now I think we're pretty sure we know what kinetic energy of particles is. It's about how they move, whether it's in a solid, liquid or gas. Potential energy can be thought about as a kind of elastic energy associated with the bonds between particles. We know that the bonds within solids are very, very strong, so there's a very high potential energy between the particles. We know that it's less in a gas because obviously those particles are very spread out and moving very rapidly. Coming back to this idea of a system, it could mean the air in a room, for example. A system could refer to the water sitting in a beaker. It could refer to the gas in a petrol engine cylinder. In fact, a system can be anything that we define. So, what happens to the internal energy of a system if we increase the temperature? Pause the video for a moment and see if you can come up with an answer. As the temperature increases, the increased thermal energy is transferred into kinetic energy. That means that the particles will vibrate more or move more quickly. Now it's quite difficult to calculate the internal energy of a system, and we don't do that at GCSE. However, we have already met an equation that enables us to calculate the energy needed to increase the temperature of a system, and therefore how that increase in temperature is related to the increase in internal energy, although we probably didn't think about it in that way when we met it in the energy unit. Now we've already met the equation energy equals mass times specific heat capacity times change in temperature, which we sometimes write as E equals mc delta theta, where delta theta means change in temperature. We also looked at a definition of specific heat capacity, which is that it is the amount of energy needed to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. That was back in the energy topic. Now, in fact, this is the amount of energy needed to heat something up. Then this is an equation that tells us how much energy is needed to raise the internal energy of a substance. If you can't remember learning about specific heat capacity, I'd recommend at this point going back and looking at the energy unit, either in your notes or BBC Bite Size or free science lessons on YouTube, and just recap what it is and perhaps have a look back at the calculations you did. The other thing we looked at in that first unit was a required practical where you are asked to find out the specific heat capacity of a substance. That could be water or it could be a block of metal. So what I'd like you to have a think about now is how you would do that, what equipment you would need, and what measurements you would need to take. I suggest you pause the video at this point and see if you can jot some notes down before having a look at the answer on the next slide. So here I've written out a suggested method for finding the specific heat capacity, in this case of water. You'll notice I've used numbered steps. I think this is a really good way of laying out a method, making sure you haven't forgotten anything and making it very easy for an examiner to see and mark. You'll notice that every time I've said that I'm going to measure something, I've also said what I'm measuring it with. This is really important because a lot of students forget to do that. They'll just say they're measuring the temperature or the mass. Always say which piece of equipment you're going to use. Again, you'll see here I've talked about a voltmeter and then later on said that I'm measuring voltage. I've mentioned ammeter and again saying I'm using it to measure current. So in each case I'm making that really clear. Again here I've got measuring time and stop clock. The other really important thing to notice is that I also make it very clear what calculations I'm going to do. And again, this is something I find students quite often forget to do. Hopefully that's a good example for you. And if I were you, I'd have a little look at that and perhaps have a go at writing one out for yourself. Finally, here are some other places you might look if you want to get some more information about internal energy. I'm referring you to BBC Bitesize, to the particles topic, also to the free science lessons on YouTube, again to the particles topic, or of course you can look in your team's documents.